have made it. Welcome.
Hell yeah. So
Hi.
we're super excited. It's LuigiBlood's turn. It's time for Satellaview reverse engineering. So y'all haven't heard of it. It's a satellite modem for the SNES. It's a really, really cool history of it. There's a lot of really interesting things that happened with the Satellaview. And so LuigiBlood is going to go and tell us all about what he has learned and how he was, or his approach to reverse engineering it. So super stoked. LuigiBlood, you ready to go?
Yeah.
Hell yeah. Take it away, man.
So hi, I'm LuigiBlood, and I will talk about how I reverse engineered the Satellaview with the best of my ability to speak English. So this talk will be I will present what the Satellaview is. Then I will talk about how I reverse engineered it as someone who didn't know really much of anything. And then I will talk about how it actually works on to how that what we know of it today, and then pretty much like what I've learned out of this process. So first, I need to explain what I do for the most part. Most of my focus has been about mostly obscure Nintendo things. So I've been working on Satellaview. I've been doing some 64-bit preservation and emulation, and I've done some e-reader stuff in the past. Hopefully, I will get back to it. And then, if you know me a little bit, you know that I have done some CDI stuff in the past with some HD high quality rips. And so my knowledge, like in 2010, so when I started to reverse engineer Satellaview, I learned programming with BASIC. The next thing I've done was a Hello World homebrew for the Super Nintendo. It was quite a mess of code when I look back to it. And every time I try to do something, I ask everyone all the time. I expected other people to do stuff for me. That's pretty much what was my level at the time. And it was also like, I was like around 15 or something, just to give you an idea of where I was when I was about to do this kind of project. So now let's talk about the Satellaview. So the Satellaview is a peripheral for the Super Famicom that allows you to access a satellite broadcast service that was managed by Nintendo and Saint Giga. You could download games, magazines, additional content for some games that support it. And you could also listen to radio, which was something that Saint Giga was pretty much all about. And some games also use the radio broadcast as part of the experience. It's also a thing that Nintendo doesn't like to acknowledge all the time. Sometimes they do release stuff, and sometimes they like to bring some attention, like in Super Mario Odyssey, but most of the time they just don't talk about it. So one of the main reasons why I was into the Satellaview was really the games. There were many like original games that came out for it, between a new Zelda game, a remake of the first Zelda, but in somewhat different way. There was also some Mario games, some really obscure stuff that you would never see anywhere else. Some games like Radical Dreamers, which was a sort of Chrono Cross, some kind of Chrono Cross prequel, or rather a draft of the game that originally came out on Satellaview. And then there were tons of other original games that came out for it, and sometimes they were released as a cartridge. So now, how did I begin reverse engineering? Well, first of all, I looked up most of what I could find about the system. I did not care at the time if the information was accurate. I just tried to look for everything that I could. And at the time, I had a basic register listing, which was just which registers we use, but none of their purposes. And then a bit of emulation code for memory packs that were in emulators. That was pretty much all that I could find at the time. And the hardest thing with Super NES is really like in 2010, debugging was a mess. They were really limited to pretty much just tracing and breakpoints, and that was about it. There was also like a disassembler, but it was only a DOS application, so I had to pull up some emulator for it. But most of my work, most of what I did was tracing, and lots of patience to figure out what is even happening. So to give you an idea of what I do, I decided to talk about the first thing I pretty much reverse engineered, which was the memory pack, because it has the most information, at least at the time. And basically what it is just a flash memory storage. It was 8 megabits, which is 1 megabyte if you do the calculation. There were apparently 4 types of them, and it requires a compatible cartridge, which is the BSX or any other games that used it, like RPG Maker. So we go a little bit technical on how I try to figure out if there was like anything to figure out. And it mentions something about vendor information, and you could enable it by writing some values into the memory. And then I don't know if I don't like, there was like MP, so I assumed like it was about some kind of ID. And then there was another value in there, which was pretty much something like we didn't really know much about. And this thing says 1A. So to figure out that stuff, I was rather lazy at the time, so I did a run hack instead. I did figure out where the BSX cartridge loaded this information, and I replaced it with just a hard-coded value instead, which is explained here. And then I found out like the game that I had loaded in the emulator was loading like 4 times for some reason. There was a list of 4 times the same game. And then I figured out, like, with some more tracing and stuff, I found out like when I changed 1A to 1C, it was reading 4 times the amount of the memory, which meant that instead of 8 megabits, it was 32 megabits. So that's interesting because it's not something that ever came out. But just by doing this, I kind of figured out that most of the reverse engineering technique that I figured out on pretty much my own. I use a disassembler for just to get to the code that I want without necessarily going to trace logs, which I did use then to figure out the flow of the code. And then I did lots of blind ROM hacking, which is probably not the best thing to do, because then you don't necessarily understand what would have happened. Sometimes when I do that stuff, nothing really is noticeable. But it's always much faster to get an idea of what I'm doing and hopefully get into more detail later. And then I figured out like some of the BSX save data. I will explain BSX a little bit later. How to download content, and how to use the memory pack. So writing, reading, erasing, and that's all of that. I've kept like logs of what I did before, like in forum posts, and especially video logs where I've shown my progress throughout all this reverse engineering. So you can still find all of them like on YouTube, on my channel. And then in the middle of all that, I stopped everything because something happened, and that was no cache SNES. This simulator is made by Martin Korf, aka No Cache, and this person is also known for making a huge amount of documentation and also just being really good at reverse engineering. And this documentation came with full documentation of downloaded content. It also came with like full documentation of the BSX and how it had a scripting engine and everything. So basically, my stuff pretty much stopped right there. And then it was just all about using that work and hopefully get somewhere with it. So that's basically how I did most of what I figured out throughout the whole thing. But now let's talk about like the actual thing of pretty much everything we know of. So first of all, I would like to talk about the BSX cartridge because it's the thing that pretty much was the base of all reverse engineering because it was pretty much a BIOS ROM for using the Satellaview hardware. And it is pretty complicated sometimes because this cartridge is unique because it uses a very unique mapper that is only used for this. And basically, it has a memory pack slot and then a mapper that maps the BIOS RAM, the PS RAM, the SRAM. And then there's something else that we found out that according to a patent, it was internal flash memory, but it was removed. So that was pretty interesting. And then the chip that managed all of this is called the memory map controller and security chip, which contains the memory map controller and the SIG chip that makes the cartridge work on the Super Nintendo or Super Famicom in this case. So let's explain what the BIOS ROM is about. So the BIOS ROM, like, it has most of the basic functions to use the Satellaview and memory pack. It also came with a bytecode engine, which is used for most of the interface, but also some magazines that came out. There's also like some kind of operating system with a trading system. And also, obviously, the menu and also fonts that games also used. But the most interesting thing about the functions of the BIOS ROM is that you can update them. There is a jump table in the SRAM where most of the functions from the BSX BIOS ROM are called from. There is a lot of jumps in that part where you could just pretty much replace the jump to another part of SRAM which contain the updated code, and then jump back to the BSX ROM whenever that's necessary. It also has menu saves and game saves, which some of the parts of the SRAM has proper checksum checks to make sure if it's corrupted or not. And basically, the BSX is like a whole like RPG like menu, which is so Nintendo really tried to make this as friendly as possible, but also a little bit charming. It looks like Earthbound, but it's not actually developed by any. There is actually no real stuff in common between these two, which is interesting. And the thing with like BSX is that there are also a lot of NPCs. You could set up also the season. There is also like a fountain in the center of the town where you could change it to pretty much almost anything. And there is also a building that you can change to whatever you want. So basically, the BSX use download service that are pretty much all the time. Some of them are short-term updates, and some of them are long-term. For short-term, you pretty much downloads like constantly all the time. And this data is pretty much like a status ID, which basically means if it changes, that means the data is different now. So it replaces the data with the news. There is also a directory ID, which I will explain later. There is also an audio setup where you could set up pretty much if you want to enable sound effects, music, or the radio, or not. And then there's also a bunch of NPCs you can enable. With like a maximum of 5 with some exceptions, and then a list of available file IDs, which is pretty much like when something can be downloaded, it's available on this service data. Then the first thing that it downloads is pretty much a welcome message, where as soon as you connect, as soon as you start up the town, you see a message, and it could be pretty much anything that you want to write. And then in terms of long term, there is the directory which contains an ID, which if it does not correspond to the town status, then it will update. And it contains a list of folders which contain files or items, because since the menu is pretty much an RPG, you can also buy items that are mostly useless. And then there is also expansion data, which contains the event plaza, which is the building that you can change to pretty much anything. You can bring in palettes, graphics, and also like where is the door in that building. And you can also bring custom bytecode for custom NPCs. And then there is a patch system where you just bring the address and data. That's how it updates the BIOS on the SRAM. Folders are pretty much like every building and NPCs that you can find, which means that you can also change. You can make them a shop for items. You can also make them an NPC that gets you to download a game or other content. So, and you can also make them say pretty much anything you want, since the folder contains a name and also a description, which is actually like the first thing that you see when you talk to them, or pretty much when you go to the building. And then now, let's talk about Satellaview. So that was pretty much the basics of what the BSX does. But now let's talk about like how it actually downloads stuff. So the Satellaview is pretty simple. On the outside, you can see that there is a BSIN port, which contains the bitstream of everything it downloads. It plugs to the extension ports for the Super Famicom. and you can also notice that there is also an extension port on the Satellaview, which is a custom IDE port kind of thing, and where you can use it for a hard drive or maybe make an adapter for compact flash, which is what someone else did. And what's inside is pretty much a PCM decoder for the audio, for the radio, something called the SPR BSA, which is just an EEPROM which contains the serial number of the Satellaview. And then the main brain of it all is the data channel decoder, which is not just doing what it says what it means. So first, to explain what the data channel decoder can do, we have to talk about what's in the satellite data. What's in the bitstream is pretty much like a constant frame after frame of that contains PCM audio channels, which can be like up to 4 of them. So you can do like up to 2 stereo tracks of audio. And then there is a data channel which contains pretty much everything else, including the games and BSX service data. There is also error correction for everything. And that's the part that we don't, and not everything that we entirely understand yet. First of all, before it gets to the data channel decoder, it goes to the MN8892221, which goes pretty much like this. It descrambles the data, the interleaves, and then it manages the audio for itself, and then sends the data to the data channel decoder, so then it can do what it needs to do. So the data channel decoder is not just a decoder, it's pretty much how you communicate to the Satellaview all the time. The data channel decoder, first of all, there's what it is supposed to do with the data, but it can also do some power management, which pretty much powers on the decoder, the PCM decoder, and the LED. There is a general purpose input-output, which is mostly used for the extension ports, as well as muting the PCM audio if need be. There is also a serial interface to access the EEPROM and the PCM decoder. And then it also brings a custom IDE bus interface for the extension ports. So the data channel, so I have to explain what it contains. Basically, one packet contains all of these things. It contains a prefix, which contains the logical channel, which basically is pretty much an ID for the data. Whether the packet is the first or the last or none of these or both, because obviously you can't just put every data in 32 bytes. So it's pretty much a chain of packets. And then there is a continuity index, which is mostly used to make sure there's nothing missing in between. And then also some additional error correction for everything. Then there is the data stream register set. So that's what the Super Nintendo can access, and that's what the BSX use. There is a logical channel selector, which basically adds like a way to select, to make sure what data we need. There is a prefix counter, which basically is about like the amount of packets that's in the buffer. A prefix first in, first out, where you get the prefix data. Also a data FIFO for the data. and also an OR gate, which is used every time you read the prefix. It actually ORs the data into another register, so you can just check that register for every packet that you're about to get, and you can easily figure out if there's an error or not. So here's pretty much how the data channel decoder works. The data channel goes to an LCR I compare. So if what you select is the core, so if the data channel packet goes to the data channel decoder, it only gets it only captures, so to speak, the packet that we want with the right LCI. Then it performs checks with some checksums and continuity checks, and then it puts everything into the prefix first in, first out, and the data. And then after that, everything is pretty much handled by the BSX BIOS or any other cartridge that may support this. This is it for the technical part. Personally, I don't want people to use the real hardware except for documentation or possibly other special cases that maybe we hear about in the future. So what did I learn out of this? So first of all, when I reverse engineered the Satellaview, I learned pretty much low-level system knowledge of this. I learned how to RAM hack properly. Also learned like a bit of hardware knowledge. So when I look at hardware, I can get a basic idea of what I'm looking for and how to document stuff. Everything that I learned from the Satellaview was used to figure out the 64DD. So that's pretty much the end of this talk. There are a lot of people who worked on Satellaview preservation and documentation, and a lot are still being discovered today. So I really would like to thank Davy Pocket, like in the last few years, for helping figure out how the satellite data actually is. And maybe we'll be able to use the actual Satellaview to figure out how it works, and then maybe provide like proper experiences via the internet on emulation. So that's pretty much it for this talk. Thank you for listening.
Yo, that was amazing.
Yes, thank you very
Thank
much.
you.
Yeah, that was some really good stuff. So
I'm amazed that I made like in 30 minutes.
Yeah.
I thought it was going to be shorter for a second and then longer.
Well,
I mean, that was good.
Thank you very much.
We could
really
hear it all day.
Low-level stuff here. I'd love to, hear you talk all day. But we have our next panel coming up. So if anybody has any questions for LuigiBlood or wants to talk, please go to the AirGap Discord and use the stream Q&A channel if you want to ask any questions or talk, given however much time LuigiBlood actually has. But yeah, that's what we're talking about stuff. So, and yeah, we don't have a Discord, but we're not that fancy here. Here's a link to this. Boom. Alrighty. So Remy, are we going to be restarting real quick the stream?
Yeah, I believe we will be restarting right now for just